In this section, we're going to talk about finding the slope of a line that passes through a pair of points. Let's say we're given the points -2, 4, and let's say 1 and 3. Okay, we know how to graph a line when we know at least 2 points on that line because we did it with the x and y intercept. But what we're going to do now is we're going to derive what's called the slope of a line that contains these 2 points. And very quickly, the slope of a line is defined as the rise over run, okay? Or it's change in x over change in y over change in x. We have 2 points here. Both of them have an x and y coordinate. So we're going to get the slope by subtracting the y coordinates and dividing it by the difference in the x coordinates, and we'll see that in a second. But first of all, let's start out by drawing a picture here. Let's go ahead and graph this just to get an idea of what we're looking at. So we have 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. It's definitely very helpful when you draw a picture of something, especially when you're just learning a concept, because it helps you get a better grasp of what's going on. So let's plot the first one. We have -2 and 4. So 1, 2, 1, 2, 3, 4. All right, here's our first point. Then we have 1 and 1, 2, 3. So let's go ahead and connect these 2 points using a line. And then this is our line here for these 2 points. Now, if you notice, it's tilting downward. So a good reason to to graph this line of these 2 points before finding the slope is you'll notice that you're going to have a negative slope. Whenever it's tilting down this way, it's going to be negative. When it's tilting up, it's going to be positive. So let's go ahead and plug these in. Let's call this point 1 and this point 2. So this is point 1 and this is point 2. So to find the slope, we're going to find the change in y. So we're going to have 4 minus 3. And we're going to divide by the change in x. We're going to have a -2 minus 1. So this gives us 1 over, change that to a +2 negative, -3. So the slope of this line is a -1/3. And it's actually a good way to check our answer if we draw the graph. We graph the number line, because if this came out to be a positive answer, we know we got something wrong, because as you can see, this is a negative slope. It's sloping downwards. Okay, let's do a few more of these examples. Let's go ahead and find the slope of the points 3, 3, or the slope of the line that contains the points 3, 3, and -3, -3. Okay, so how do we find the slope? Well, our slope is, let's call this point 1 and point 2. We're gonna divide the difference in y's over our difference in x coordinates. So we have a 3, this one right here, minus a -3. So let's be careful with our signs. Divided by the change in x. So we have 3 minus a -3. Remember, we're getting the difference of the numbers, so we want to make sure we have our signs correct. Okay, these negative signs cancel, and so do these. So we have 3 plus 3 is 6, and 3 plus 3 is 6. So our slope is 1. And that means for every one step we go on our x-axis in the positive direction, we'll go up 1 step in the positive direction. So this would have a slope somewhat like this. It would look like this. So it would be more like a stair step. Okay, let's do another one. Let's find the slope of the line that contains the points 0, 0, and 1, 4. Okay, so we simply call this point 1 and point 2. It actually doesn't matter. You can call this point 1 and this point 2, and it'll actually work the same. But we find the change in y, so 0 minus 4, divided by the change in x, so 0 minus 1. These are our 2 x terms, these are our 2 y terms. So 0 minus 1. This will give us a -4 over a -1. The two negatives cancel, so our slope is 4 over 1, or just 4. And that's our slope. Just to prove that we can actually use either points, let's do the exact opposite. Let's subtract 4 from 0. Let's call this point 1 and this point 2. So 4 minus 0 is the change in y, and 1 minus 0 is a change in x. So we ended up with 4 over 1, or just 4. Okay, so we can see by swapping the points, we actually still get the same slope, because it doesn't matter which way you're looking. If you're going this way or going this way, the slope is the same. Okay, pretty interesting to think about. Let's do a few more of these. Let's take a look at the line that contains -2, the point -2 minus 1, and the point 0, 3. All right, we find the slope by subtracting our 2 points. We subtract the y coordinates, so -1 minus 3. We divide that by the difference in the x coordinates, so -2 minus 0. This gives us, let's add a negative, it gives us a -4 over a -2. The negatives cancel, and 4 over 2 is the same as 2, so we have a slope of 2. Okay, let's make sure we didn't make any mistakes. 3 minus 1, okay. So the slope of this is 2. Let's do another one. Let's take a look at the points 0, 2, and 0, minus 2. Okay, so let's go ahead and find the slope of these. This is point 1, this is point 2. So we subtract 2 and -2, so 2 minus a -2, divided by the change in x, 0 minus 0, well that's just 0. These two cancel, so we have 4 divided by 0. Now, this is actually going to lead to an undefined slope. Remember, we can't have 0 in the denominator. So if we actually take a look at plotting this, you'll see why. Let's plot this real quick. 1, 2, 3, 4. Okay, that's pretty much all we need. Okay, so our slope is 4, 0. So if we start in the origin here and we go up 1, 2, 3, 4, and we're not going anywhere in the x direction, we can also go in the same direction. This line is going to run straight up and down. It's actually not going to have any slope. But before we say our slope is 0, we find that we have a 0 in the denominator. Division by 0 is a no-no. Division by 0 leads to infinity and gives us what we call an undefined slope. So the slope here is actually undefined. And this is actually the case of all vertical lines, not just the ones that go on the y-axis. It could be over here, it could be over here. All these have an undefined slope, which gets a little technical when you get into higher mathematics. But for now, we're going to call division by 0 undefined, or an infinite slope. So we're running out of time here, so we'll do a few more of these in the next video.